Now let's come back to the contest. Charlotte Barberon from the International School of Luxembourg will defend her project to the members of the jury. Personally, I'm really excited to hear more about this project. It's called Why Couldn't the Chicken Cross the Roads? The project investigates the calcium content of tibiotarsus bones from chicken raised in battery farms compared to chicken raised in open-air farms.
Hello, I'm Charlotte Barberon, and I would like to start my presentation by asking you a question inspired by a joke that I'm sure you're already familiar with. So why couldn't the chicken cross the road? And my answer to this is because it had osteoporosis. So why would I say something like that? Well, my answer is actually based on reality. Because 6% of battery farm chickens suffer from skeletal abnormalities such as osteoporosis. So what are battery farms? They're the farms in which chickens are raised where they're in very small and crowded cages, as you can see in the picture. Typically, these chickens are fed calcium-deficient diets, and they're given very little access to physical activity. And they're also fed too quickly and too much relative to their normal skeletal development. So as a result, about 2% of chickens raised in battery farms die of lameness every year. And this actually causes $4 billion of losses for the chicken industry every year. So clearly that's a very important issue that we need to resolve. And luckily, there are other types of chicken raising methods, such as open-air farms. In open-air farms, the chickens are slow-growing breeds. They have more access to physical activity because they're outdoors, and they also are allowed to live longer lives before they're slaughtered. And this slow growth and more physical activity leads to a process called dynamic loading. Dynamic loading is when the chicken's bones will become stronger because of increased strains and stresses that have been placed upon the bone over time. So an example of this would, for example, be when a tennis player hits a ball with a racket. What happens is that the forces will squash and bend the bones, and then the bones, to accommodate for these forces, will become stronger through increased bone size, bone density, or mineral content. So in my presentation today, I'm going to share with you some basic information about my experiment, some key stages of my methodology, the results, and finally the conclusions. So this was my research question, and I was looking at how the method in which a chicken is raised, whether this is in a small battery farm or in an open-air farm, will affect the strength of its bone. And so to look at the strength of bone, I looked at the mass percentage of calcium in one tibiotarsus bone. So I looked at 5 different chicken farms. 2 of those were battery farms, and then the last 3 were open-air farms. So now moving on to the methodology. The first stage was to extract all the calcium from the bones. And I did this by crushing up the bones, drying them, and then placing them in 1 molar hydrochloric acid. And the acid would react with the calcium ions, extract it, and put it into solution. Then the second stage was to prepare 0.1 molar EDTA solution, which we will use later on. In the third stage, I prepared the Analyte. So the Analyte contained the bone and metal cation solution that we prepared in the first stage. It also contained ammonia buffer, because I needed it to be at a pH of about 10 for the experiment to work, deionized water, as well as EBT indicator. EBT indicator will form a complex with the calcium ions and give this pretty red-purple color that you can see here. So this was my titration setup. So I poured in the EDTA, titrated in the EDTA into my Analyte, and the result was a color change that you can see on the right. So what happens is the EDTA replaces the EBT and forms its own compound with the calcium. As a result, the EBT is now left alone, unbound to any calcium, and it gives the blue color that we can see here. So then I knew that as soon as my solution turned a permanent blue color, all the calcium had bound to the EDTA, the EBT was alone, and I had that color. So from this, I was able to calculate the volume of EDTA, moles of EDTA, and because it reacts in a 1-to-1 ratio with calcium, I could calculate the moles of calcium quite easily. And then finally, the last stage was to look at the mass percentage of calcium in each tibiotarsus bone. So these are my results, and what I found was that in the open-air large chicken farms, on average, 1 bone had about 19% mass of calcium, whereas in the battery farms with the small crowded cages, there was only 13% of calcium in each bone. So what does this mean? That means that overall there was a 27% difference between my two samples. So the open-air farm chicken bones had 27% more calcium than the battery farm chicken bones. So that's a pretty big difference, but is it big enough? Well, I performed the Mann-Whitney U test, and I showed that my samples did have a statistical difference, which suggests that my results were valid. So now looking at the conclusions. So how can we explain this process? Well, the results can be explained by what I explained in the beginning of this presentation, which is the open-air versus battery farm situation. So in open-air farms, the chickens have more access to outdoors, they can have more physical activity, the bones can strengthen, and therefore increase their bone mineral content, including calcium ion content. And so this is actually supported by other experiments done in the past. For example, Mayer and Sund showed that when you exercise chickens from battery farms on a treadmill, they will actually lower their incidence of bone breakage. And then Rowland and Harms also did a similar experiment, and they showed that chickens with less physical activity will indeed have a lower tibia ash percentage. Tibia ash percentage is basically another measure for the bone mineral content. So, what are the takeaways that we can get from this? So I think that something for the future that could be really interesting would be to look at the difference in the bone strengths between battery farm chickens in Europe compared to battery farm chickens in the United States. Because in the EU, we have specifically defined 5 freedoms for farm animals, whereas in the United States, there are still some controversial practices like chicken debeaking, which are illegal in the EU. So we could look at how the different legislations will affect the bone strength, and therefore we can see what kind of laws best promote animal welfare. Okay, so this is just my works cited. So overall, I hope that we have seen today how the difference between open-air farms and battery farms on the well-being of chickens, and we've especially highlighted the dangers of battery farming on chicken welfare. So perhaps next time you are out grocery shopping looking for a chicken for dinner, you might want to consider looking at the open-air options. So together, we can change our consumer habits and therefore influence the way in which chickens and animals in general are raised. And together, therefore, we can let the chicken grow strong enough bones to finally be able to cross the road. Or not. Thank you.